Okay, hello everybody. This is your host, Jennifer Brennan. Welcome to the NASA Earth Data webinar, Improving Accessibility and Use of NASA Earth Science Data. While everybody's logging in here, although I see some of you have already noticed the two polls at the bottom left and middle of your page, we'd appreciate your feedback on those polls. I've got 2 p.m. Eastern Daylight Savings Time, so let's go ahead and get started. What I'd like to do first is to go over a few housekeeping items related to the webinar. First of all, to ensure best audio experience, the conference has been placed in silent mode. If you have any issues or questions, please enter them into the Q&A pod located on the lower right-hand corner of your screen. This works like a chat. The webinar itself will be recorded and posted to our NASA Online Adobe Connect event catalog as well as to our NASA Earth Data YouTube channel. These URLs will be provided to you at the end. All presentation files are also available for download at the end of the webinar. The webinar itself is 1 hour long. 45 minutes are allocated to the presentation and demonstration, with another 15 minutes for the question and answer period. After our speakers have finished their presentations, what we'll do next is we'll move to the final set of polling questions. The question and answer period will directly follow. As I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar by using the Q&A pod. Due to the large number of participants, however, what we won't do is answer questions using the raising hand function. It has been disabled. Again, we'll take all questions using the Q&A pod at the end. And just one final note, depending upon the volume of questions that are received, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. for those of you who might wish to stay on the line. So I'd like to move next to the agenda. During the first few minutes, our first speaker will provide you with a brief introduction to the NASA Langley Atmospheric Science Data Center Distributed Active Archive Center, or the ASDC DAAC. We will then switch speakers. Our second speaker will describe the geospatial architecture at ASDC DAAC, provide a use case example using power, surface meteorology, and solar energy, or the SSE data, and then the final section of his presentation will focus on GDAL enhancements made for NASA's Earth Science Data and Information System, or ESDIS project. At this point, we'll then move to the demonstration portion of the webinar. Okay, our two speakers today are Tisdale at the NASA Langley Atmospheric Science Data Center, DAAC. Matthew is the lead for the Advanced Architecture and Engineering team, with Brian serving as support on the same team. It is my pleasure to introduce our first speaker today, Matthew Tisdale.
Thanks, Jennifer. So today we're going to be discussing how we're improving the accessibility and use of NASA Earth Science data. Again, I'm Matthew Tisdale, and I'll be starting the presentation today. So improving the accessibility and use of NASA Earth Science data and geospatial applications. And starting, the ASD is increasingly seeing users trying to access their data products using open source and commercial geospatial tools. Due to the formats many of these data products are in, mainly HDF4, HDF5, and NetCDF, these tools have not worked well with these data products in years past. Many geospatial applications, such as ArcGIS, are now building more functionality to support these scientific data formats. In order to better serve the geospatial community, the ASDC has been working with ArcGIS platform to serve out ASDC products through geospatial web services. These geospatial web services improve on the accessibility and usability of the ASDC data holdings by making them increasingly easier to pull directly into various applications. Today we will first focus on a brief introduction of the ASDC, the geospatial technology being used here at the ASDC, a specific use case for this technology, and then provide a short high-level demo. So the ASDC at a glance. The ASDC focuses on 4 different areas of atmospheric science, specifically the Earth's radiation budget, clouds, aerosols, and tropospheric chemistry. The data stored at the ASDC come from various instruments on spacecrafts orbiting the Earth. For the radiation budget, we have an instrument known as CERES, which is the Cloud and Earth's Radiant Energy System. And for clouds, we have CALIPSO, which is the Cloud, Aerosol, LIDAR, and Infrared Pathfinder Satellite Observations. MISR, which is the Multi-Angle Imaging Spectroradiometer. For aerosols, we have CALIPSO mentioned before, as well as MISR, the multi-imaging spectroradiometer, and SAGE-3, which is stratospheric aerosol and gas experiment. And for tropospheric chemistry, we have MOPITT, which is measurements of pollution in the troposphere, as well as TESS, which is tropospheric emission spectrometer. From all these instruments, we house a large number of data sets here. On the top of the slide here, you can see where we house 3.5 petabytes of data in the archive. And we've distributed this to over 165,000 customers in 158 countries, of that being 624 terabytes of data that were sent out. So this is a large number of data that we store here at ASDC that we're looking to find new ways that we can get this out to users and make that easier to use versus downloading in our traditional way through FTP servers, that we can start to expose this data through services. So data discovery and access through web services. As I mentioned before, by providing out through these standardized web services, we're promoting interoperability. So we can push these data sets out through these various services, and these can be pulled into applications that implement these standards. In our case, we're going to focus today on the ArcGIS image service. So we have a NASA Enterprise License Agreement with Esri that allows our agency to acquire ArcGIS software at no additional cost. So we're going to utilize ArcGIS, but we're not just locked into the ArcGIS platform. We can also provide these out in other compliance services that other applications can use. So as you can see in the below list, some of these could be desktop applications. Some of these could be portals where you can find other services and applications to integrate along with ours, as well as the ArcGIS platform suite, which Brian is going to provide more information on in the following slides. So I'll now transition over to Brian to continue on.
Thanks, Matt. So what is the ArcGIS platform? So it's a suite of tools that includes server components, portals, desktops, and mobile and web applications that allows users to create, organize, and share geographic information with anyone by using these online maps and apps. And the power of this is allows you to do end-to-end geospatial information analysis and distribution. So here at the ASDC, we're looking to leverage the ability to do modeling and charts, as well as pushing analysis into different types of workflows and ultimately exposing that information through web apps and mobile apps. So how are we going to do that? So leveraging the ArcGIS platform, we now have this end-to-end solution that allows us to do processing, analysis, visualization of NASA's scientific data. So we're leveraging the ArcGIS multidimensional mosaic data set, a new capability in ArcGIS 10.3 that allows us to spatially and temporally aggregate our data from the source repositories into a service compatible with the ArcGIS platform. So we're really focusing on exposing that data as a service, and then in theory, everything else just works with the ArcGIS platform. And this is important that here at the data center, most of our data sets, as Matt mentioned, is stored in these HDF and NetCDF libraries. And traditionally, you would have to download these data sets, do some type of reprocessing, and get it in a format compatible with ArcGIS or other geospatial applications, such as GeoTIFFs. However, what we're focused on now is looking at how do we build that service layer on top of our data repositories so that we don't have to replicate data, we don't have to reprocess it into different formats in order to be able to use it within the suite of tools. And now with this new capability at ArcGIS 10.3, we've been able to do that. So what is the Mosaic data set? So it allows you to store, manage, view, and query small to vast collections of raster data. It consists of a catalog that provides the source of the rasters and a set of mosaic rules that are used dynamically to mosaic the rasters. And in addition, it can be used as the source for serving these image services that we're speaking of. So as an example here, at the data center, we host what's known as the solar radiation budget. It's composed of 22 years of daily data stored within over 8,000 NetCDFs. Each NetCDF has 20 plus parameters per day. So if a user traditionally wants to go and download and say, I only want to look at one parameter, let's use temperature for example, and I'm only looking for a certain time period, they would have to go in and download all the NetCDFs for those days. That includes all the additional parameters that they may not be interested in. So what we've done is loaded those 8,000 NetCDFs into the raster mosaic, which created over 190,000 plus raster metadata records. So, we did not load the data. This is just metadata records about what type of rasters are contained within each of those NetCDFs. So once the raster mosaic is set up, we can then build these raster function templates. And they allow us to do the mosaic and to deliver a dynamic mosaic image by applying on-the-fly processing operations such as orthorectification, reprojection, interpolation, and image algebra. And you can apply these functions to the entire mosaic dataset or to individual rasters. This type of functionality is going to allow us here at the ASDC to save disk space, since we won't be required to store both source and reprocessed datasets. And some example use cases that we're already implementing here is if a user per se wants to see their data in Fahrenheit versus Celsius. Previously, most individuals would have to download that data, write an algorithm, reprocess it to Fahrenheit, and then store that output to a new data set. Now we can build these on-the-fly processing templates that allows the user to quickly just say, please present the data in a Fahrenheit format. On the fly, we can run that algorithm, present the result back, and then the user can download, if they choose, just that output. We also often convert our data to local solar time, the solar radiation budget data that I mentioned. Currently, that's a separate product that we create. We go through each data set, we reprocess those daily NetCDFs as a local solar time product and make that available additionally for download. Using these processing templates, we believe in the future we will no longer need to do that. And you can also create new variables. So as part of the Surface Meteorology and Solar Energy project, we provide out data for wind U and V vectors. And you can write an algorithm to combine those into wind speed. So as I previously mentioned, same type of challenge with current users. You would have to go and download the separate wind and U and V parameters, write your own algorithm to develop wind speed, and then save that separately. Now we can just develop this on-the-fly processing template that allows wind speed to be generated from those U and V parameters on a daily basis as new data comes available. So ArcGIS also provides several hundred analytical and temporal tools for raster and feature analysis. And these are Python functions, and with the use of Model Builder, you can just drag and drop them to develop complex workflows without extensive knowledge of Python. So as I mentioned before, with these raster function templates, you can define what your on-the-fly processing is, and then quickly build that into a workflow that allows that data to be continuously reprocessed, leveraging those templates. And then after all the data processing is done, ultimately we're looking to expose this information for visualization purposes. So now that we've got our data stored in this multidimensional mosaic data set, our users can now visualize that data to look at temporal changes of a variable, looking at multiple dimensions of a data set, and even calculating, visualizing flow direction and magnitude of variables. So in this example you see here, you're looking at wind speed and wind direction on one map. Whereas previously you would have to look at those as two different variables. We're now able to visualize it using color scale for one and direction of the arrow for the other. So by combining all of these capabilities of the ArcGIS platform, we're able to expose this information and leverage that end-to-end solution for doing our processing and analysis and visualization of our scientific data here at the data center. And then once these services are available, our users can start to develop web applications to expose that information to our community mission partners. And also new at 10.3 is the ability to create multidimensional web applications. So as I mentioned before, many of our data sets have temporal and depth information. So now there's web applications, pre-built templates that allow us to look at multiple depths of a data set as well as the time change of those data sets. And not only can we visualize it, we can also create graphs, graphical representations, and embed those in the apps as well. And also, that's getting very popular in the geospatial community is the use of story maps. So the idea that if there's something unique in your data set and you want to tell a story similar to you're writing a research paper and there's something that you really want to highlight, you can create this interactive experience for your user, walking them through the steps, telling them the story of what's occurring in your data, and allowing them to interact with the data as you're doing so. And these are pre-built templates that the ArcGIS platform provides to quickly create these applications. And here at the data center, we're also leveraging the ArcGIS portal capability, which provides for discoverability of all of our services, the tools, maps, and apps that are being developed. In addition to that, we are in discussions with the geospatialplatform.gov effort as well as data.gov so that our portal can be federated with these systems to increase discoverability. An example of that would be, you may not know that the ASDC has solar radiation budget web services available, but you as a geospatial power user is very familiar with ArcGIS Online or the geospatial platform where all federal public data is being federated to. So you could go to the geospatial platform, search for solar radiation budget, and our services are going to appear. And when you add those to the map, you're actually connecting to the services here at the data center. But it gives you the ability to mash up our data with other data from across the community. So now I'm going to do a quick highlight of a use case that we've already stood up services for, and now we're looking at how to leverage those to improve the user's experience. So here at the Langley Research Center, we've teamed up with the Power, Surface Meteorology, and Solar Energy Project, whose mission is to improve the nation's public and private capability for integrating environmental data from NASA, satellite-based analysis, and modeling research into sound management of energy production and energy efficiency systems. So below you'll see two screenshots of the current website. So it's a text-driven website. It's been around for a very long time that has a huge user base. So currently you come to the site, you select which parameters you're interested in, insert your latitude and longitude, the date ranges you're interested in, make that submission, and you return a series of data tables or ASCII text files. And then it's on you as a user to determine how you're going to process that data and use it within your analysis or as inputs to your applications. And there's really no graphical capability currently on the site. So we saw an opportunity here to improve this experience to better serve our customers. So what we've done is started to the development of a web application built on that same data to ultimately enhance the accessibility and usability of that information. So as you'll see in the screenshot, we now have an application that provides high-quality viewing and printing of those data sets. So not only do you have access to the data tables, but you can also visualize those if you want to do some comparisons before you go out and decide which information you want to download. When you are ready to download, there's built-in data extraction and subsetting tools. And you can also swipe between layers. So if you want to compare one month to another, that ability is there, and you can quickly do that. And then you also can go through any day of time. So for example, with our solar radiation budget data set, that's 22 years worth of data that's going to be available to do that temporal analysis. And you can select your own color ramps. And then ultimately render that as an image that you can download. Or if you're interested in the data itself, you'll be able to go and download that as well. And Matt will provide a more detailed demonstration of this in the demo portion of this presentation. So we have had some challenges with using our NASA scientific data within the ArcGIS suite of tools. So I wanted to highlight that and also talk about some efforts that we have underway to increase the support of these types of data sets. So you'll notice here on the left side in the column titled in ArcMap 10.2.2, some data sets that we host here at the data center. So you're looking at initially MOPITT. When we originally loaded this data set into the ArcGIS desktop application, we were noticing the image was being inverted. The second one down was a different product. However, as an HDF5 format, it was rotating it. And then also an example here with tests, when we tried to load the data set, simply didn't know what data to load, and we were just getting this black strip of information. However, we do have an effort underway here to look at, in partnership with Esri, GMU, and the HDF group, to look at how can we build plugins in order to address this. And I'll talk about that in more detail, but I just want to show on the right that we were able to successfully do this, where now those data sets are renderable in the ArcGIS platform and can now be added to our Mosaic data set. So how did we do that? We really focused on the HDF drivers within the Geospatial Data Abstraction Library. The GDAL library is what most geospatial tools use for doing the raster rendering. So ArcGIS, as well as other geospatial tools, all use this library in order to render raster data sets. So we took a close look at it and determined that if we could revise the HDF drivers, we could implement the fixes needed to correct our data sets. So what we since did was built a series of plugins within these drivers that allows you to fix known issues. So if you know that your data set is rotating, might be missing georeference information, or is missing special metadata tags that the GDAL library is traditionally looking for in order to render your data correctly, you can now augment those changes with a series of plugins, then allowing you to render your data in the ArcGIS or other geospatial suite of tools. So we're in phase 2 of this effort. We've done a proof of concept here at the ASDC and have shown that it is feasible to do this. And then over the next 6 months, we're going to be coordinating with other DAACs to look at what types of issues they're seeing with using their data in ArcGIS or other geospatial tools, and creating a series of plugins and tutorials on how you can implement this. And then ultimately, we want to add this to the open source GDAL branch so that not only ArcGIS that we're focused on today, but other geospatial applications that use the GDAL library can also benefit and then be able to render our NASA's data appropriately. So with that, I'm going to turn it back over to Matt to give a detailed demo of the things we've discussed.
Thanks, Brian. So we're going to start out. We'll go into our ArcGIS for server. So these are the services that we were talking about earlier, and this is how you would discover these. So here you can see, we see the power folder. So some of those were in the discussion and slides previously. If we drill into this, we can actually see some of those services that are available. The first one here being temperature from 1983 to 2005 at 10 meters above the surface. So we're just going to go and look at more detail about this service. So here we get some basic metadata about that service. So we can see what area that covers, some of the time information contained in that service, as well as if there was a description of that service, what it contains. If we scroll down further, we can get even more information. And at the very bottom, you can see some of these supported operations in the blue highlighted text. These supported operations are the functions that can be run on these services. So these aren't just basic services to identify metadata, but we can also interact with these services through our web browser and through our applications. We're going to look at the identify operation just as an example here. So now that we have the identify operation pulled up, the ArcGIS server gives us a basic GUI to interact with this service. So we can fill in information in each one of these boxes, and then it's going to make a request to that server asking for that information. We'll go ahead and just put in some information here for the geometry. So this is asking the service to return the information contained at the point at -3540 for this service. And at the bottom, you can see that we get a return of these properties and values. Those properties and values represent the temperature at that point across this data set. As you can see, this data set runs from 1984 in January to December 31st. So each one of those points is each day in that service and what that temperature was at that location. So this is quite a long list that's returned back from the service. If we scroll down, we also get some other information. So this contains information that's in the catalog for that service. So information about each one of those layers for each one of those days that we had. And if we wanted more information, we could look to this. So now that we've seen the service through the ArcGIS Service Manager, we want to look at an easier way to access this. So it would be tedious for a user to go in there to interact with that service and put in all those information for each query they're making to that service. So what we can utilize is some applications that will directly put some of that information in for us and make this quite a bit easier. So we'll come into ArcGIS for desktop, and we'll click on the GIS servers folder over here and then add ArcGIS server. Once we do that, we're prompted to use GIS services, so we'll click that and then click next. Here we'll type in the server URL. So this is the address of that web page we were just looking at. So this is where the location of those services are. In this case, this address. So we'll click finish on that, which will then add that service directory to our ArcGIS for desktop. And you can see those same folders that we just saw before in the web browser. So again, we'll dig into the power directory there. And then we see the same services that are available. So again, we're going to focus on that temperature service that was available. So we'll click on that and drag it into our map, loading the data or loading the service into our map viewer. We can see right now it's just a gray block because it doesn't know what information we're interested in. As I mentioned before with that service, there's a lot of layers there for each day. So we need to be able to select out a day and what parameter we're interested in out of this service. So just as an example here, we'll open the attribute table for this service. And here we're presented with the same information we were seeing before in the catalog from the web viewer, but now it's in a more formatted format so that we can actually see the names of all the layers and the data that's contained in there. So you can see these are monthly averages for each one of these months over the 22-year period from 1983 to 2005. So now we actually want to make this more visible and usable within this ArcGIS desktop application. So we're going to right-click on the service, go to Properties, click on this definition query. So this is going to let us query out the data that we're interested in viewing within this application. So we'll select the name equals, and this is selecting out that attribute that we just saw in the catalog for one of these particular sets of data. So we're looking at the annual average in this case. So we'll select that, put the query in, hit OK. And so now we've got the query in. Now we want to change some of the visualization properties of that service. So we want to edit the high and low values. You can see those are out of range for the temperature that we're looking at. So we're going to look and focus at -50 to 50 degrees Celsius. And then we also want to change the color bar. Instead of this boring gray to black and white color ramp, let's put some color into this image. So we're going to select another color ramp that distinguishes features a little bit better. So we'll make those changes, hit OK, and apply that. And now we can see that our image has actually changed. So this is actually interacting directly with that service, providing these parameters back to that service and telling it what we'd like to see. So now we get our nice colored image returned back. So this is a lot easier way to interact with the service versus filling in all those parameters that it was asking for before within the web browser. So that's one way to interact with the service. If you're a powerful user and you want to use it directly in your desktop application, you could use ArcGIS for desktop to connect to the services. But if you're a user that doesn't have ArcGIS for desktop, or if you don't want to bother with directly accessing it on your desktop, there are ways that we can do this over the web as well. So all these services are available over HTTP and HTTPS, so we can directly consume those in online applications. This is an example here of our geospatial portal, another ArcGIS product that allows us to more easily search for those services, apps, and applications that we're developing here at the ASDC. So this is the front-end interface where we'd come in, and as an anonymous user just coming to the website for the first time, you'd be presented with all the services and applications that are available to you. We're going to click on one of these just to launch as an example to show what one of these applications would look like. So here we're in the SSE GIS map. On the left side, you can see a list of all the different layers. So these are a list of all the different services that we've already pre-configured and arranged into this web application. So the user doesn't have to individually search for all these. They're just there, and if a user clicks on one of the squares to the left, it'll actually load the data for that service. So we'll just scroll down and click on temperature at 10 meters annual. So these are the annual temperatures from 1983 to 2005. at 10 meters above the Earth's surface. So we can see it's already pre-colored as well, so we've done a lot of the work on the back end to go ahead and make these services easier to use within this web application so that the user doesn't have to change all the configuration settings up front. But if they want to, they could also change the coloring and some of the other information from the service. And just to show you sort of how we were doing identify before in desktop, if we just click on the map, it's doing that same operation where it's asking the server to return the temperature at that location. But it's just sending that in the background where the user doesn't have to know exactly how that's happening. They can just click on the map and get the temperature returned from this map service. So you can see here the value of 16.17 degrees Celsius for this location we just clicked. So these services aren't just nice visualizations, they also have the real data on the back end that you can interact with. So we'll just zoom out here and look at the entire map of the Earth here with our data overlaid on top of it. And then we'll look at changing some of the base maps. So maybe we don't want to have this imagery that's already preloaded in this map. Maybe we want to look at street information or some other data. We can change the base map that's available with this service. So we'll click on the base map here at the top left and then select our streets base map. So you can see that the base map is now changed, and you can see that it's got some labels and some other things that are different about this base map. We'll zoom in so that we can see a little bit more detail about the streets. If we're interested in a particular area and want to see in more detail where this area was, the streets may help us identify where we're looking at. So we'll just zoom in here to North America and then focus on the Hampton Roads area as we zoom in. So you can see as I zoom in, more and more information is appearing from this base map service that we've just added in. And if we zoom in one more level, you can now see the various streets and major interstates in the area and how those relate to our data. So what we can also do is change the transparency of layers. So if we're interested in seeing more of the data that we're interested in, it's hard to tell what these temperature ranges exactly are based on the coloring of this map. So maybe we want to change that so that we see our data better versus the base map. So we can change the transparency so that all we see is our data. So if we want to look at that and have a better visualization of that, we can do that. And then if we're also more interested in the base map, we can quickly change that transparency to see the base map below it. So now that we've looked at the transparency settings, let's jump back to our default extent and zoom back out to the full globe in this area. So now that we've done that, let's look at a time-enabled layer. So the data we were showing before was just averages over a time period. Now say we have daily data for each one of those temperatures. In this service here, we have temperature from 1984, from January, all the way up till December in 1984. So each day now has its unique image per day. So if we want to start playing through those, we can easily add this layer now, and you can see a time slider has appeared at the bottom of the screen. So we can start to play through this time to see how it changes on the map. So we'll just click through a few of these just to see the time change. You can see at each click, it's actually making a request back to the server to request new data for that service that we're showing for that particular day. So this is a great capability to be able to interact with a service that has time enabled on it. So you could overlay these with multiple data sets if you're interested in. So everything we were showing thus far has really been focused on a user just coming right to the website. What we can also do is there's additional capabilities that we can build into the portal if a user has a login and password. So this is how we're configuring a lot of the web apps on the back end to present to those users. So as you just saw before, that SSE GIS web application was built the same way, and we pre-configured it for the users. So once we are logged in here, we'll be presented with a new interface. So this takes us back to the SSE GIS map, but in the top right, you can see that we are now logged into the portal, and we can start to publish more interactive applications and add features to this capability. So we'll click on, at the top of the screen there, the share, And you can see we can select what groups we want to share within the portal. So if we want to have this web application or services available to a specific group of users, then we can enable that. Or if we want to share it with the entire user community of the portal, we can do that as well. And then as a follow-on, we can also make a web application. So not only just sharing, but now we want to add some more capabilities and features to this web map that we have. So let's build a web application by clicking this Make a Web Application button. From here, we're presented with a list of templates that are already available through the portal's interface. So these are pre-configured, quick ways to get a map up and running, as Brian had mentioned earlier, with these templates that are available through the portal. So we'll just look at the third set here, and you see these story maps. So as Brian mentioned before, story maps are a great way to show different data sets. So if you want a user to be able to see the information that you're talking about, you can select what layers appear, where they appear at, and for how long they appear before going to another location. So these are great ways to show data and to talk about what you're seeing within the data. And you can also do comparisons between data sets and layers within these story maps. So for example here, we'll just preview a story map. And this one's presented with two layers. So here we have the temperature in August and December. And the spyglass here that you see in the center of the screen is letting us see through one of those layers so that we can easily visually compare the data between these two time periods. So we'll just move this this viewer around on the screen so that we can actually see through these two data sets through this spyglass. So as we move it around, it becomes easy to see the differences between the two data sets. So we can visually see the difference between August and December between these two data sets. So this is just one example of how we can publish out a web application to then show differences between two data layers. So if we want to add more functionality beyond just a spyglass, we can actually build a custom web app that then uses a lot of different features within an application. So for more advanced functionality, we go to the Web App Builder tab up here, and we'll click Get Started. So now we're brought to a new interface that lets us build an application. So this is using a graphical interface for the portal that lets you easily just drag and drop applications and widgets and then make changes to those without actually directly having to modify the code. So for this example, we'll just look at the themes first. So if we want to change the theming of the web app, we can do that. So we'll just come in here, and you can see the layer list here, where we actually have this X button in the top right corner. So if a user had limited screen, we may want to let them be able to close the layer list and move that around where they'd like on the screen. So we'll just go ahead and turn the temperature on just so you can see visually in the background. And then we'll go to switch this template, the theming, to this tab theme. So now once it's on the tab theme, you can see the user no longer has this X to be able to close out the layer list. They can push it over to the side of the window if they want, but they're never actually losing this interface to access the layer list and some of the other capabilities. So depending on how you want the user to interact with your web application, you can configure the themes and how they look to the user. So with that, we'll switch back to the original theme and keep the temperature at 10 meters annual as our layer that we're selecting for the service. We'll now look at some of the widgets that are available as part of this web application. So you can see here, there's quite a few that are out of the box. So we have a geocoder if we wanted to geocode locations and then add those to the map. We have a home button so we can jump back to a default view if we want to have like a global view for our data set. The My Location, which will zoom you to your location based on the GPS coordinates of the device that you're using. And so for an example, we'll just go ahead and load one of those. So we'll click on one, and we'll go to our web app here in our widget and select the draw tool. So we'll add that. We can now customize any of the features of that web application and tool. So if we wanted to switch the units, we could do that, and each one of these widgets would have its own features that we can modify before adding it to the application. So once it's added, then a user would be able to come in. You can see it's now added to our number one there. And then we could select, in this case, it's a drawing tool, so we can draw on the map if we'd like. So we can select how we'd like to draw, and then what we'd like that to look like. We won't actually draw on the map in this case. We're just showing the example here of being able to add the widget to the web application. So once we've got the widgets, we can also then look at how different interfaces and different devices will display our web application. So in this example, we have a web browser that we could also then rotate to see how it would look. But we also want to look at how this would interact on mobile devices. So maybe we want to look at an iPhone 6 and see how it would look on the screen of the iPhone 6 and what would be the best layout and configuration for that. We can switch it to a Samsung Note, see what it would look like on that device, and then even rotate it to see if the user were to switch the orientation, how would the map adjust to accommodate that. One of the great capabilities about this is that we can write an application one time and then deploy it to all these different devices to be able to be used. We don't have to write an application specific to iOS or Android or to Windows Mobile to be able to interact with these devices. We can write this application once and use it by many different devices. So just an example here, as Brian mentioned before, the Power SSE application. So this is an application that we've stood up for the SSE team, and we're looking to build out functionality moving forward. Initially in the application, you can click on the eye in the top right. This gives you some information about the SSE project, as well as what data sets and data layers are available within the application. We can click on the layer list. This presents us with all the layers that are available as those services so that we could click on a few of these if we were interested to see more data. And in this case, we'll turn on temperature at 10 meters and for March and the annual average, just as a comparison. So here we're presented the legend, so you can see the Celsius, degrees Celsius from -50 to 50 for each one of these. So they're using the same color ramp and scale. And then we can start to look at some of the widgets that we've added as part of this capability. So we're going to look at the swipe tool, similar to the spyglass that we showed earlier. This lets us swipe between two different layers. So if we quickly want to visually see the difference between these, we can look at it this way versus the spyglass previously. So you can see the difference between the temperatures in March and then the annual averages between these two. So now that we've done the swipe, let's look at the Find My Location tool. So we can click on the Find My Location, and this is going to use our GPS coordinates from our device or our browser to figure out where we're located. In this case, we're in Hampton, Virginia. So it's going to jump to our Hampton, Virginia location, and we can see on the map the imagery behind there, as well as the data set overlaid. We'll zoom out and go to the full view and then turn on a different layer. So now we're going to look again at a time-enabled layer within this particular web application. So as before we saw with the templates, we were presented with a time slider. In this case, if we click on the play for the layer that we have that's time-enabled, we're presented with a different time slider within this application that can be moved around or positioned so it doesn't interfere with the data being viewed on screen. In this case, we'll just play through a couple of days of data here so that you can see how this animates across this data layer. And this, again, is making a request to the server each time for one of these images that's being requested and then replied back to this web application. And then as a follow-on, if a user is interested in downloading the data directly, they can click on the Download button in the top right and then get a list of all the layers that are available within this web map and how to directly access those. So if they want to save them directly to their desktop versus interacting with these in a service through the application or within ArcGIS for desktop through the service, they can actually download these directly to their machine and then do some analysis and processing. So that was a quick overview of the demo that we put together, showing how we're utilizing some of these services and applications as well as through the web browser. So we're opening this for beta access first, and then we'll be pushing this out as a public release shortly. And as you saw, we're initially focused on getting the services stood up and providing out these for visualization tools. What we'd really like to do in the future, once we have all these services available, is to then look at how geospatial processing can be done and processing on the web so that users could use these services directly in processing tools and do the processing within the web without actually having to download a lot of these files directly to their computer to be able to do this that processing. They can do it right over the web and through their interface of their choosing. So with that, I'll turn it back to Jennifer.
Okay, thank you, Matt. Thank you, Brian. Thanks, everybody. So what we'll do next is we will move along to the final set of polling questions, and I usually like to give these just a couple minutes or so, and from there we will move directly to the question and answer portion of this webinar. So please be sure to stay in the room and or stay on the line to participate in the Q&A period. All right, thank you. Okay, so I don't see any further activity with the polling questions, but certainly if you have any additional feedback after the fact, please feel free to email me or email either one of the speakers, and they'll be able to address your questions once the webinar has been completed. So with that, let's go ahead and move to the question and answer period. All right, you'll notice in the lower right-hand corner of your screen, the presentation files from today are available for download. You've got the presentation file both in PDF and also in PowerPoint format. And what you'll need to do here is simply select the file. If you put your mouse on any one of the files and click, you will have an opportunity to then download the file. It will be highlighted. And at the end of the webinar, when we're done with Q&A, I will leave the room open for a few minutes for those of you who may wish to download the files. And this is also a persistent feature, so if you wish to download the files later, when you listen to the recording at a later date, if you choose to, you would still be able to download these very same files. So let's take a look now at the questions that we've got. Okay. Let's see. The first question is, what do we mean by raster exactly? And I had entered an answer, but I just want to confirm this with the speakers. So raster data meaning gridded remotely sensed data. Is that accurate, Brian and Matt?
Yeah, that is correct. Here we utilize a lot of gridded data products that come from our instruments. So these are regularly spaced grids with a value associated at each one of those grid points for that particular measurement that was made.
Okay, great. Thank you, Matt. Our next question is, it's more of a comment really, and it's ArcGIS is a paid software. Is this capability available only to users who have ArcGIS?
No, it's not. So we are focused here at the data center of leveraging the ArcGIS platform as our technology for providing out the services. But our services will be provided in an ArcGIS compatible format, but as well as an open geospatial consortium compliant formats that allows for open source geospatial applications like QGIS to access our web services as well.
Okay, thank you, Brian. Our next question is there a URL for the production server to query data this way? And kind of in the same vein as the previous question, available to the public?
So currently it's not available to the public. We're doing a beta right now, but shortly we will be releasing all these services and applications to the public so that users could then pull those directly into their own applications or directly access the services if they'd like. Contact us if you'd like any information about getting into the beta in the near term.
Okay, great. Thank you, Matt. And then let's see here. Our next question is, can we save the visualization into a video or movie?
So you do have the ability to save the visualization. The capability is not currently there to download a video. However, you can download a series of images. But we will take note of that and look into the capability of doing some type of visual or video recording of the animations.
Okay, thanks, Brian. Our next question is, how can I find out more about the incorrect geospatial rendering in ArcGIS and how it was corrected?
So please reach out to us. Our emails are on the slide, so I encourage you to reach out to us. But also, as part of this phase 2 effort that we're just starting, we're going to be engaging all of the DAACs to learn about the issues that they have as well. So if you're affiliated with one of the DAACs, we're looking forward to talking to you soon. Otherwise, please reach out to us.
Okay, thanks, guys. So the next question is, can you give us an idea of the time required to crunch through the NetCDF time series data to calculate temperature, and then in parentheses, an example use case from one of your slides?
Yeah, really it depends on the number of data that we have, but really it's on our end to push those into these mosaics first. So as you saw in the demo when we were accessing the services, once they're loaded, it's really just a time to then send that information back to the user, which is very fast. So the big load time is on our end, loading those into the mosaic, but once they're in those mosaics and we can serve them out as services, they're very fast to access over the web.
Okay, thank you, Matt. I've got another question here. Is there any demo or instruction manual of ArcGIS present in this website?
Currently, there isn't a tutorial, but we're looking to record some demos and provide some documentation on our website for how to access these services and applications and how to use those. So those will be coming shortly once we release the ArcGIS applications for public use for those services and applications.
Okay, thank you, Matt. So I do have another question, and actually it's more of a comment now that I look at this. When I mentioned using your data, solar insolation, etc., with SAM, I was referring to Solar Advisor Model by the NREL. I think I am way over my head, but I'll ask anyway. Do you have any feedback on this?
Yep, so I'm not familiar whether or not that data set is part of the solar radiation budget data that the SSE project utilizes, but we will follow up with the science team, and if not, make them aware of it. So, appreciate
Okay.
it.
All right, thank you. And also, Fernando, this is something that we can follow up with you a bit more offline. So thank you for the comment and question. The next question is, will I be able to connect to these image services, do my own custom geoprocessing to the data, and then create a map service or display it into my own ArcGIS server?
Right. So currently we just are focusing on getting the services out, but what we'd really like to do moving forward is being able to do just that, so that users can directly interact with these, run their processing right within their tool and application without actually having to download the data, so they can interact directly with these services. So that is definitely some functionality that we want to add, and we'll be promoting that as we move forward once we get all the services in place.
Okay, thanks, Matt. Do we have any further questions? I don't see any additional questions at this time, so while I give participants just a couple more minutes to consider whether or not they've got questions, I'd like to mention to all of you that you see on the slide to the left here, we do have several different social media accounts if you're interested in connecting with us, where I will post information regarding new data tools, new data products, upcoming webinars, both on the Facebook as well as the Twitter and Google Plus accounts. For the Google Plus and YouTube, you would do a search for NASA Earthdata. All of our webinars are posted to the YouTube account, so this will be posted in the next couple of days. And then if you're interested in signing up for a email listserv where I will email out announcements for upcoming webinars, you can find that at the tinyurl.com Earthdata webinar URL at the bottom of this slide. All right. Any further questions? Okay, everybody. Well, I certainly thank you for joining us today. If there are no further questions, we will then hang up the telecon, and I will leave the room open for a few minutes for those of you who may be interested in downloading the files. Okay, thank you for joining us today. Thank you, Brian. Thank you, Matt.
Thanks.
All right, bye-bye now.